All right, now let's talk about our acid nomenclature. Remember, if I'm looking at a formula, I have to figure out what type of compound I have before I know what rules to use to name it. We've talked about ionic, we're looking for metals there, we're looking for Roman numerals, we're looking for IDE endings maybe. But now, with the acids are a dead giveaway because you're always going to have an H out front. H out front means you use your acid rules. And remember, we use the ending of our anion, if you go back a couple slides, to translate to a new acid name. Why it's tradition, I could not tell you, but it's just something we have to memorize. So I have H2SO3. I know I need to use my acid rules because of this H out front. Then I look at everything else. Everything else is SO3. I have more than 2 elements in this compound, so I should be thinking polyatomic ion. And when I go to my polyatomic ions, I find that SO3 we call sulfite. Now this ITE ending means that we translate to an OUS acid suffix. So we take our stem, our sulf, and I'm going to add an extra syllable because that's what we call it, makes it a little easier to say. And I add my OUS ending. So this is sulfurous. And then I have to have the word acid because the word acid translates to H out front or H plus in the compound. So H2SO3 is sulfurous acid. Now let's try the next one, H2SO4. We know we have an acid because of the H out front. So now I double check with everything else. The fact that I have more than 2 elements in this compound means I should be thinking polyatomic ion. And when I look at my polyatomic ions, I find that SO4 is sulfate. Sulfate. That ATE ending translates to ick acid. Remember, I ate something icky. So this is sulfuric acid. Then the last one. We still know it's an acid because of that H out front. But I only have 2 elements, so I shouldn't be thinking polyatomic ion. So this S really just comes from sulfur. But remember, we give it that IDE ending. So this is sulfide. Well, sulfide. So IDE is the only acid name that also gets a prefix. So this translates to hydro blank ic acid. So sulfide becomes hydrosulfuric acid. Hydrosulfuric acid. Now, what about the other direction? Lucky for us, the word acid is a dead giveaway that you have an acid. That, at least, is straightforward. And the word acid means that you should have an H plus. Now I go to the rest of my name. I'm looking at this OUS ending. Now for these names, we have to translate backwards. So OUS came from ITE. Ite to us to ite. And then we look at our stem, chlor. So chlorous acid came from chlorite. And remember that chlorite is a polyatomic ion that is ClO2 with a 1- charge. Now you see that I'm setting you up for a drop swap here, and so I'm going to do just that. And when I drop swap, I should have 1 of each ion to give me HClO2, chlorous acid. Now let's try the next one. Again, the word acid is a dead giveaway for H+. We have a new ending. We have ick. Ick, with no prefix, came from 8. And then my stem chlor goes in front. So chlorate is a polyatomic ion, ClO3-. Again, I'm setting you up for a drop swap. I'm going to have 1 of each ion for this drop swap to give me HClO3. hydrochloric acid. And now the last one. Still have acid, still a dead giveaway for H+. But I have my prefix, hydro-ic. That means this came from an IDE ending. I use my stem, so that came from chloride. Remember, IDE refers to elements. So I have to find chlorine on the periodic table, and it has a charge of 1-, according to the group that it's in. Again, I'm setting you up for a drop swap. And this is going to give me HCl. So the formula for hydrochloric acid is HCl.